Journey with me back to the Middle Ages, or maybe even a little earlier. And people discovered that if they put up a tent, and maybe the tent had been used a few times and had a hole in it, on a sunny day, the light would come through the hole in the side of this tent, and they could see on the far wall of the tent the whole world outside of the tent. A projection. It was even more interesting in that the projection was upside down. For a while, this was kind of a parlor trick, but then they began to use it for things. And maybe some of you already know the story. It was a great disappointment to me to discover that the artists of the Enlightenment frequently used this trick to sketch their picture before they painted it. Indeed, they could project this still life scene that they wanted and then, in essence, come up with a paint by numbers where they went in and colorized it. I thought these guys were so good. In any case, they decided to name this. It was the classical world, so of course they used Latin, and they called it the camera obscura. And I know not many of you need me to help you with Latin, but for the one or two of you who don't know Latin, camera means room, and obscura means dark. And so they had a dark room with a hole in the wall, and bingo, they could project the world. We've got one here. Our dark room is this white box. Our hole in the wall is this opening. We'd like to see what's going on, and you're outside of the room. So we will remove the camera, and so now you can see the opening and the back wall. We have light sources over here. The light is going to come through and go out and hit the wall. This is actually part of a real camera. So for the moment, we're going to remove these lenses to show you how we can make it a pinhole camera. So if we turn this around, you can see there's a big opening here. That's not much of a pinhole, is it? But cameras have the ability to change the opening that lets light in, or aperture. And so we can shrink this down, and we're going to do this and show you the results. And that is going to be the pinhole that this light comes through and lands on the screen. We are going to change it, and you'll see the results of having a small opening and a large opening. You will find that there's some good points and bad points to that. We are then going to show you why the addition of lenses is a huge improvement, and why almost none of your cameras are pinhole cameras, and almost all of them have lenses. So we've now got our pinhole held in place, and we have a screen. And you can see the result of the lights shining through the pinhole. We have the red light on the bottom, green light on the top, and it's clear that as the light passes through the pinhole, the diagonal paths make the positions switch. The opening here is very wide. It gives us a pretty bright image, but because it's wide, there are many paths from the light source to the screen because the opening has some width to it. If we shrink that width, we limit the path to fewer and fewer light rays until the hole is a point and there's only one line that connects the 3 points of the red source, the hole, and the screen. When we do that, we get a fairly sharp image, but of course it's not very bright because the hole is small. So this was the problem with the camera obscura. Either your image was sharp and dim, or it was bright and very blurry. This is where lenses changed everything, because now we've got this great big opening with kind of unsorted light rays coming through it. But if we install lenses, and what a lens is, of course, is a curved piece of glass that causes the light rays to bend. By choosing the curve right, that bending can be an organizing principle, so any light that leaves the red filament ends up at one spot on the screen, and any light that leaves the green filament ends up at another. And so we can gather up all of these diverse green rays, organize them with the lens, and land them on the screen in exactly their appropriate spot. And so now we see very clear images of both filaments. It's quite clear that these are thin wires that have been heated up to the point that they glow. And we have colored gels covering the lights to force the colors into the red and the green. And once again, we'll emphasize the red bulb is on the bottom, the green bulb is on the top. After you pass through this point of the pinhole, there's been a crossing. The pinhole is at the crossing of this X of lines, and the light originating at the bottom shows up landing at the top of the image on the screen.